Check to see if the sound is on and all that.
Well, we can only pray now.
The internet can totally see you now. Así lo mandas.
I'll make sure everything's on. Uh-oh. Okay. So we're on there. We're on there. Let's send it to these folks.
No timestamps today?
I guess not.
That was the other problem that I thought whenever I'm not here. There's no timestamps. A bummer. Timestamps are really important for videos that are kind of longer than 20 minutes or something.
Oh, is that what it was?
Any long video. It's nice to have like a glossary or a table of contents.
Let's see, put it here also, just in case. Okay, we're there. Okay.
I'm finally getting to see what happens on this side. Everything's done. Countdown goes up.
And now we go in there. Hello, everyone. And we're back on the air after a little detour in time. We had some time dilation over here. Anyways, a little bit about what we're about, and that's that let's put it in a very easy way to understand. If you find something wrong with or suspect some of the things that you're hearing from the establishment, black holes, Big Bang, parallel universes, many copies of you, each one in a different universe. Every time you move a finger, you end up in a different universe. Zero particles, zero dimensional particles, particle duality, wave packets. Well, if you suspect some of those things, some of the things you're hearing every day, they sound counterintuitive. Well, maybe this is the show for you. Otherwise,
I don't think that's what gets people. I think
No?
it's more just the
Okay.
simpler questions of
Uh-huh.
how does gravity work? How does magnetism work? Because it's not that they get bad answers. It's more that they just don't get answers.
Yeah, but I think a lot of people are concerned about what they're listening out there. And one of the issues is also that you listen to these things day after day after day. Just take any popularization magazine or journal or whatever. And what will you find? You'll find the same thing said over and over and over again. They found the first black hole. The black hole has so much mass, and every galaxy has a black hole in it.
Yeah,
And it's just over and over and over. You'll be hearing this until kingdom come.
The other day, I got into a really long discussion with some friends about black hole and their existence, and it just dragged on forever.
Yeah, you had like an 8 hour.
Yeah. And we were playing some game, but then all of a sudden that came up, and we started, like, as the discussion went on, like, it started off fun and games, but as it goes on, you stop playing the game. We stopped playing the game less, and we were more into the discussion. But it just shows how kind of deep this feeling of, like, what we know, how deep that runs.
Yeah, and then there's
when you question what someone knows.
Yeah, so essentially, what do we see as irrational, as counterintuitive, as what is wrong with what we're listening to coming from the establishment? It's that they are in the business of moving concepts. Um, love does not move mountains. Not in physics. Maybe in poetry, but not in physics. And this is more or less what you see every day. You hear about transfer of energy, moving of mass, dilating time, and we read about this. We are educated to use these words in high school, and it turns out that all these are concepts. And the question is whether physics is about the physical world or about the abstract world. In other words, can you move an abstraction? Can you move a concept? And I think the answer, a rational person would say, no, you can't. And if you can't, then we have a problem with what the establishment is putting out there, because all their words are concepts, especially where a invisible entity is involved as a mediator. Then they introduce concepts. They say, oh, that's energy. And you say, well, what is energy? What is a field? What is mass? And that's where you run into trouble, because these words, first of all, are not defined. Second, they're used differently by different people depending on the context. And then they're all concepts. And so you can't say that you moved a mass, you transferred energy. And that's essentially the bottom line with all this. That's the main big point there. And what we're trying to do instead is provide a physical interpretation.
Or a literal interpretation.
Yeah, literal interpretation. What do we mean by that? We mean that you can make a movie of the theory.
Or you can imagine it.
Yeah, in other words, I can make a movie and you can watch it and you can understand the mechanism. That doesn't mean you believe in what I'm putting
It's funny,
out there.
I thought about that when I was building the faucet, because our faucet broke. And the instructions of building the faucet, there's no language there. It's just pictures. Which screw goes where. And I was just thinking, like,
no energy?
It's just interesting when you see the instructions, because it's supposed to be like for dummies. But you see the instructions and there's no language. It's just like
pictures,
arrows and motions in like arrow form.
Yeah.
But it's all pictures so that anyone can understand it. It's self-evident if you follow the instructions. It's that kind of thing. And I just thought of like, this is a physical recipe.
Yeah, I can imagine you making a movie of that. Frame by frame. This is
that's how it is.
Part
step
A,
1,
B,
step 2,
C,
step 3, step
right.
4. That's essentially the most important frames.
Yeah.
It's a 10-frame movie.
Yeah.
Each one is just the crucial frame that you need to know. You don't need to know all the steps in between, like moving your arm into the thing.
But the main point here, again, is we don't move concepts, or we object to the motion of concepts.
Because it's supposed to be literal.
Yeah, physics is literal. Mother Nature does not work with concepts, hopefully. Hopefully she works out there with physical objects. And if that's the case, then there should be no reason to explain a mechanism like gravity or magnetism or how the atom works with physical object. You make a movie and you say, look, this is what I propose. It's not what you're supposed to believe, it's what you're supposed to understand. I explain, you understand, that's the end of physics right there. You understood, whether you believe or not, that's your personal business. Anyways, we don't have a great show today. All I wanted to let you know is that we came back from a little recess. We were on the road, and now we're going to continue on the road. We're going to go to Argentina, where we have a petite conference, and it's going to be about these issues. What we're going to do our best to do here is we're going to take some of the equipment down south and see if we can broadcast from Argentina. The first thing, we're going to broadcast the conference, if we can do that, and I think we can, but you never know until you get there. But so I don't want to promise. I'm just going to promise that I will do my best to make sure that we can have a transmission. And while we're down there, even after the conference, we might hold a couple sessions, a couple lectures, and broadcast those as well. So stay tuned, especially all those people who are affiliated with Patreon. And, we're going to try to transmit and broadcast over here. Okay. What else? Is there anything else we got to talk about?
I won't be here.
Yeah, well, okay. An's here. He's my youngest son. He's a skinhead, more or less. Yeah.
No, not anymore.
No, not anymore.
You
okay.
grew up.
I'm getting to be a skinhead little by little.
Against your will.
Yeah, I don't think I'll need an air blower, hair dryer. anyways, we're gonna go down there. He might stay down there. If he does, we might have a weird situation where he's gonna participate from Argentina, ask questions, get involved as well.
It's for sure going to be a different show for maybe 2 months.
Yeah, for a couple months, we're going to have a little bit of different shows, so be aware of that. And other than that, nothing much except stay tuned for the broadcasts that are coming up. Okay. And again, only if you believe that there's something wrong in what you hear out there and it's counterintuitive to you, then this might be the show for you. You're going to hear a different bell.
Another way of thinking about it is we're kind of like the simplified version.
Uh-huh.
I mean, it's not very simple when you get into the details, but it's the simplified version because it's understandable. It's like someone can actually follow along and not have to just take things on faith and be like, okay, black holes, we'll just take that one.
And there's a couple things involved with that as well, and that's that, the question is whether Mother Nature runs a very simple universe, kindergarten universe that anybody can understand, a 10-year-old kid, or whether she runs a very complex universe that no one can understand, which is the status quo today.
I think everyone thinks the second one.
Yeah,
it's
everybody
just so unfathomable. But I think that's more awe. When people think of just the vastness of the universe, they think, how is there something instead of nothing, and all those questions. It all stems from our awe that we're even here.
Yeah, okay.
Religious people and atheists,
existence is a monster, right?
But religious people and atheists alike are just all in awe that we can eat apples and ride bikes and just live normal lives. And I think that's where people just resort to, okay, then it must be so complicated. We can't understand the mind of God kind of thing, where, I mean, even when we get into the details of the universe, of like the details, like the nitty gritty of the atom, or the vastness of like specific things like the edge of the universe, even by your hypothesis, it gets pretty weird, and you start have to bending your brain, not in irrational ways, but you kind of start having to think outside of the box a lot. And it's like, okay, I mean, just when you try to draw a carbon atom with another carbon atom, all the atoms.
And I've tried to do that.
All the atoms connected.
It's a monster. Yeah. No. But this, when I say simple, is that we have, there's a famous one-liner that is used a lot in mathematical physics, and that's that. First, the grand unified theory, and then that the universe is supposed to be simple and symmetric. And when I say it's simple and also symmetric, in fact, I'm referring to the fact that, the model we're proposing, the thing that underlies everything, is the model that consists of two atoms connected by a rope. That's how simple it is. From that model, we're going to try to explain gravity, the most important phenomena, or the invisible phenomena, gravity, the behavior of light, and magnetism and electricity,
but I think
the workings of the atom. So those are the things that we're trying to focus on. And all I'm saying is that, if you have a system consisting of a very simple and symmetric system here, two balls essentially, which is two atoms, hydrogen atoms, connected by a rope. That's as simple and as symmetric as it gets.
But I think it's the right way of saying is that the hypothesis is simple, but the consequences,
the theories,
everything that comes out of it,
yeah,
you get so many possibilities. It's kind of like the billiard, the triangle. You set it up, okay, then as soon as you hit it, you get so many possibilities. It's kind of like that, where
go into different
the other day
branches out.
The other day, the line that made me laugh was the basic hypothesis or assumption that all the atoms and neutrons, now we have a new buddy in the family, all the atoms and neutrons in the universe are made, not connected. I mean, they are connected, but they're essentially all one thread. And then in the living room, I was just like, we were talking, and I told my dad, so you and I are essentially the universe talking to itself, where the thread just kind of trying to figure out what it is. It just gets weird at some point. Or when you say there's no Big Bang, that all the matter in the universe was and always will be, I mean, it's easy to say, but then when you really start thinking
Yeah,
about
yeah,
it,
to
there was
conceptualize
no
it, yeah.
first planet, there was no first human, maybe, because if we can be now, sun explodes, but we can happen in a different area of nothingness,
Yeah.
but
No,
of the
but you
same
know,
thread.
even there,
It gets weird.
even when you look at the thread, the single thread hypothesis, the fact that we're saying all matter is connected, but not only connected, but all matter is made of this single thread, closed loop thread. Assuming, that assumption alone is as simple as it gets. I mean, I think any 10-year-old kid would understand, look, there's a single thread in the entire universe. That's what we're proposing as an assumption, right? Keep in mind, that's an assumption.
The assumption is simple, but everything that all the conclusions that you draw from a simple assumption get really weird.
Yeah. And that's the only
the fun part.
Yeah.
That's the fun part.
But the second part of that one is the fact that all these mathematical physics, they use concepts as physical objects. That's one problem. But then there's the issue of, undefined language that is used. A lot of these words are not defined. If you look up words such as energy, mass, time, the end result will be always the same. Oh, we don't know what it is. We can't define it very well, but we'll use it anyways. And that's another serious problem. And that shows again that these words are concepts that people are trying to define. And we're talking about something completely different. We're saying, look, we're saying this is a ball, this is a cat, this is a tree, this is a house, a rock. We're talking about objects, and we don't define objects. We point to them.
Yeah, but
and name them.
To the definition or undefined words part, the best analogy we came up with after so many discussions, even in front of the camera, in fact, I think we came up with it in front of the camera, was the talking to a program or a robot analogy.
Yeah, that's
because with undefined terms, essentially what you're doing is you're not putting a fine point on exactly what you're saying so that it can be followed logically, but like logic with perfect logic. It's with an undefined word, you're kind of winky, like, okay, you know what I mean? Like you're trying to find some common ground, but it's not this perfect language that can be kind of copy pasted. Essentially, language that the program could understand, could follow.
Yeah.
And it really comes down to logic. If you use a word in one way here and then another way here, just because you didn't define it specifically, because if you don't define a word precisely, then you can use it very broadly, and it kind of turns more into poetry instead of science. You're not speaking literally, and you can get away with murder, essentially.
Yeah, and that's an objective way of checking your language. Don't try to convince me. Just put it in the computer and see if you can convince the computer.
I mean, I think computer
the computer spits it back out and says, "Look, I think you're using it inconsistently, or I can't follow your instructions because I don't understand what that word means." Well, there you have an objective, way of telling whether your definition is rational.
I think computer scientists will understand the analogy.
Yeah.
Or if you use something, once you define something, the computer will always use it in a specific way.
Yeah.
And there's no such thing as a vague definition in programming or talking to a robot, because the robot doesn't have its own pool of knowledge to interpret what you said.
Yeah.
You have to give them exactly your interpretations, and that's kind of how it should be in physics. That way, the logic can be followed flawlessly.
Yeah.
Whether he listens to it, whether he listens to it, she listens to it. If you define your terms in such a way that it cannot be misunderstood, then you're doing science. Because if you're not, then you're doing poetry.
Yeah, and so that's it. We want to make sure that people who tune in are people first that are a little uncomfortable with what they hear out there. There could be people out there who simply want to listen, to hear another side of the story. There's at least two bells in every argument, and you want to hear both bells.
Or just to know what scientists are saying, because, I mean, even if I'm into black holes, I don't, my friends didn't know what a black hole is. Like, if I asked them directly, okay, what is a black hole? They don't know. Ask the scientist. So it's like, okay, if you believe in black holes and you just want to know, okay, what is a black hole without weird analogies? Or I guess the best way of saying is, what is Bill's take on what the establishment thinks black holes are?
Yeah, and
That would be one way to tune in.
that's another thing
One reason.
that we do. We do analyze a lot of what they do out there, uh, partly so that you can get your own weapons. If you're unsatisfied with what you hear out there, then you're going to hear a good analysis of what we think is wrong with what they're doing out there today, the mathematicians. And so one of the issues is to provide you with arguments, or that you at least hear arguments that you won't hear every day, from the establishment itself. You'll never see any dissent between people from the universities, people who have big names.
Or at least they won't put such a fine
Yeah,
point on their
yeah,
own flaws.
yeah, yeah.
If,
But
if
we
I come
will.
up with a theory, if they come up with a theory, obviously they're gonna have areas where they're still researching, quote unquote, but they won't put a fine point on that. They'll just say, "Oh, gravitational waves have been discovered," but they don't tell you all the problems or how it happened or all the details.
Yeah.
And here we kind of harp on the details a little too much, if you ask me. But
No, we try to, yeah, we do harp on the details because sometimes people want to know a little more, a little more, a little more. And they say, well, hold it, I didn't understand this little thing. And that takes you to another thing and
yeah,
another thing and another thing.
because the
And
devil's in
sometimes
the
you have,
details.
yeah, sometimes you got to go on that tangent for a little while and cover all those, make sure with your guadagna you cut all the, the jungle there and then come back and hopefully you continue on your journey.
When you're
And
talking physics,
yeah,
it's
yeah,
all about the details. The other
yeah.
day, in that same day when we were talking about black holes, somehow we went off into a tangent of the difference between speed and acceleration. Or if you're on a train and you throw a ball up, but it's accelerating, does it fall back in your hand? It's a simple question that anyone can
Yeah.
kind of even test. I mean, geez, and we just kept going around in circles and circles and circles, and it was just all because
With more analogies.
with more analogies and more complicated analogies. Somehow we ended up from
examples.
train, we ended up on airplane that's accelerating, or wait, the Earth is accelerating or decelerating around the sun. Okay, let me explain it with the Earth, and it just gets way more complicated with gravity, and the analogies get mumbled up. But
yeah, we do
but
like to go into those details because
but the
people
details is important.
sometimes want to know very simple examples and examples maybe they never thought about, like very simple, just throw the ball up in the air and while you're driving in a car, will it fall back in your hand? Is there a motion of the ball forward because the car moves forward? That sort of thing. Does a fly that is flying in an airplane, does it get dragged also with the airplane, or does it,
or does it weigh down on
or does
the
it
airplane?
hit the bathroom wall when
I mean,
the airplane moves forward?
these are simple kind of bro sciencey questions that you ask. Like, okay, if there's a fly flying in a plane that's also flying, does the fly weigh down on the plane? Questions like that are just like, oh, it's good to know. Like, it's not doesn't answer any big questions like when we go into the universe or like atoms, but it's just fun fact kind of thing.
No, but it does give you an idea.
Kind of fixes
it does
your
also,
logic.
yeah, it also gives you an idea of what physics is about, the real physics is about, because that these are questions of physics. Does if you throw two stones, one weighs twice as much as the other, will it fall twice as fast? Most people would say, intuitively, yeah, the heavier stone falls faster, and it turns out they fall at the same time, and you get situations like that a lot of people say, oh man, that's counterintuitive. I didn't know that. And simple things like that, sometimes you need to have, you need to analyze to some degree and explain why some such things happen.
What is the point of knowing these things?
None.
Just for fun. Huh?
Just for fun. But it wisens you in the sense that it sometimes it shocks your intuition.
But I think
many times it does.
But I think it's also about kind of knowing.
No?
It fixes your logic. It fixes your way of thinking. Because if you're trying to solve, I don't know, like some detective crime, and you have some problem with your analysis or way of breaking something down, then you end up with wrong conclusions down the line. Like, it might have unseen effects somewhere down the line. Like a crass one would be if you didn't know that gravity, pulls on you at a certain speed, or if you didn't know certain things, you could jump out of the balcony and kill yourself without knowing.
Yeah.
I mean, that's a crass one that we all kind of know. It's been established, but smaller things also kind of add up. If you have enough small physical misconceptions, they might add up to something down the line.
Yeah.
Like useful, like tool-wise speaking.
Anyways, we're going to Argentina, Buenos Aires this week, and we're going to be broadcasting from over there if we can. We're going to do our best to try to broadcast, and especially we're going to broadcast, the presentations. So don't go too far away. If you're interested, you might hear something that is interesting. Okay, and so we'll see you then. We'll see you sometime this week. Probably at the end of the week, right? Maybe around Saturday, thereabouts. We're probably going to have our first transmission. So tune in. I'm going to be putting a notice like I did today in the Rational Scientific Method group in Facebook. And it's going to be again like this on YouTube. So we're going to do our best to broadcast, to anyone who's interested. Okay, we're going to make it global. So we'll see you then. We'll see you next week, hopefully on Saturday. Okay, we'll see you then. Bye bye.
Bye, guys.
Bye.